Good morning, good afternoon, good evening, everyone, based on your location. Today we will just discuss about what is data warehousing and how it is done. So just a quick recap about myself. So I'm working with Amazon as a data engineer, and in last 10 years, almost worked on data related project only, data warehousing, data modeling, data engineering. So in our today's session, the agenda is very quite simple and very straightforward. We will understand why data warehouse, what's the need of data warehouse, and what's the difference between data warehouse and data mart. Then we have two principal founding members of data warehousing community, Ralph Kimball and Bill Inman. So we will discuss about both of them, how they design data warehouse, what's their philosophy, and what's their differences, and how company can incorporate their philosophical guidance. We'll go into deep into data warehouse architecture, how data warehouse are designed, what are architecture, what are the concept behind them, and discuss about why data warehouses fail. Every company in today's world is focused on data warehousing, but still they are not able to extract insights and trend what they're meant to be. So we will study the reason for it, why it fail, and finally we will study about what's the success formula behind creating a exactly what data warehouse is meant for. And in the last, we can have a Q&A session. So if someone has any question, they can put in the chat window. We can take it in the last, or you can also connect me on LinkedIn. So through that also on email. So through that also we can communicate and discuss about if you have any question around data warehousing and data engineering. So before going into what is data warehouse, we should understand what data warehouse is not. Because as the term says data warehouse, so we means that it's just a dumping ground. Just dump all your table from your transaction system, flat files, RDBMS table, just put the table in one system, and that is data warehouse. That is not a data warehouse. That is just a dumping ground. Similarly, it's not a copy of all the data from multiple tables. You union them together in one table or a view. You call it data warehouse. It's not data warehouse. And also data warehouse is nothing but it's not a copy of source database with the name prefix with DW, because I have seen in many companies, many projects where they just create a copy of a source database and write the name DW underscore customer. So that is not data warehouse. So what exactly is a data warehouse? If we go into definition of data warehouse, so data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management decision-making process. So there are two things very important over here. One is the quality of data warehouse, that is subject-oriented, integrated, time-variant, and non-volatile. And second is that your warehouse should support management in decision-making process. It's not like that you just create a warehouse, but it's of no use. So on the one side, it's the quality of the data warehouse, and second is the implementation, how it is used. 5 6 decades ago, everyone used to say that people who have money is as an asset. Money was an asset, then material become an asset, then time become an asset. But nowadays, information is an asset. Company which holds good amount of information that can drive insights is a company, is an organization that will last forever. So data warehouse is a process where organization extract value from their informational asset through use of this data warehouse. A data warehouse is where you store data from multiple data sources. Like for example, for any organization, you have finance system, you will have HR system, you will have sales system. So you have to get data from all the system, place it at one place, and use it for historical and trend analysis reporting. It's not just like you will only extract historical analysis from it, but you have to go for the future also. That how will our future predict using that data? So that's the use of data warehouse. And finally, the most important point, it contains a single version of truth. When you have scattered data everywhere in your organization, so maybe at one point of place it shows that $100 is the amount value. In another department it will say $50. You don't have a single version of a truth. But when you create data warehouse, you always create a single version of truth. So if data warehouse says that $100 is the amount value, then that $100 is same across all the department. It's not like that finance will say that this month revenue is only $90, whereas sales team is saying $100. Data warehouse will say it's $100. It's across all the department of the organization. So as I mentioned, the quality of data warehouse depends upon four key points: subject oriented, integrated, non-volatile, and timely manners. So first is subject oriented. What do we mean by subject oriented data warehouse? It means that the data warehouse should be organized across major subjects like customer, products, sales, HR, marketing. Similarly, focus should be on analysis and decision making using that particular data only, and not on the daily transaction data. For example, you open Amazon app, or you open any of the app and you do transaction over there, banking app, Zomato, Swiggy, and that's the transaction data. We are not bothered about transaction data, but we are focused upon the historical data. We are focused upon the completeness of data. One day data won't make any analysis or any pattern matching, but if you have 5 years, 10 years data, then you can find patterns. Okay, this is the pattern over here, this is a key component for the company, so we can decide a policy accordingly. Hence the decision should be made on the historical data, not on the current or the transactional data. The second is integrated. When I use the term integrated, means that we can get data from multiple source system. It could be heterogeneous in nature. We can have data in flat files. We can have data in RDBMS. We can have data in web streaming apps, like we can get data from Twitter. We can have data from other REST APIs also. So it's a heterogeneous mix of data. It's not that we only get only one type of data. Like we can get streaming data also. So continuous data we are flowing in into a system and do analysis on that. So integrated means that continuous source of data from any place. And second is that maintaining the standability. Just imagine you have a database in US that store revenue in the currency of US dollars. In Europe, you have a US euro as the currency. In India, US INR as the currency. Just imagine you consolidate all the three data. The amount value will be 100 USD, 10 euro, 5 INR. So will it make any sense? No. So before integrating all the data, we have to clean it and make it consistent, so that the third person who is reading it don't have to do something extra on its own. Imagine 10, 15 years ago, people used to download the data of each country manually into an Excel. Then in Excel, they used to perform formulas, apply transformation, doing macros. So this is something we have to do everything in data warehouse. We have to make consistent. We have to do the same naming convention. Like for date format, in US, they use month slash DD slash year. In India, we use DD slash MM slash YYY. So just imagine if two dates are coming from two different systems, and one is saying that month is 11, other is saying the date is 11. So there's so confusion will be there in the warehouse, and nobody would be able to extract some knowledgeable item. So it's better we have to maintain the consistency in naming convention, syntax of semantics, attribute measure. So integrated means that we have to get the data also, and also make it clean and in one format. The third is time variant. If you talk about the OLTP system or the transaction system, it only holds the current data. Just imagine you are living in New Delhi today, and tomorrow you move to Bangalore, or you play other place in Russia, or maybe in England. Your current role would be always show the current position or your current residency. But in data warehouse, we always keep all the record, all the variant of your record. For example, on November 2020, you were in Bangalore. In December 2020, you moved to Russia. Now in June 2022, you moved to London. And now in December again, 2022, you moved to New York. The OLTP system will always keep your position as New York. But in database, we will keep all the information with us, so that if any point of time we need to know how many people moved from Bangalore to New York in 2020. So we can able to identify, okay, this person was in Bangalore in 2020, but now he's in New York. So there's some attrition going on from India to US, or maybe some other reason is there. So that's why all the data in data warehouse is time variant. And time variant also means that we keep a data of at least 10, 15 years. Then only it will give good insight to us, good trend, good patterns to identify the data. Every transaction in data warehouse has a date column with attached to it. The reason being, we don't only need the data, but also the time variant only. That only way is the way where we can find, okay, this is the trend setting going on here. For example, during the COVID times, people move back to their home cities in India. So we can identify, okay, this is not the general case. This is a very special case. The people, Bangalore population got reduced from 100 to 50 in terms of IT people. So it's not like they got job into new city. It's just that something special happened like COVID, and that's why people move from one place to their hometown. That's why it's very important to know what's the time variant of that particular record. And the fourth key quality of data warehouse is that it's non-volatile. When we say non-volatile, it means that data always remain in data warehouse, irrespective of number of data, irrespective of number of transaction. It's not like transaction system where the record keeps on updating. In data warehouse, it's always inserting a new record, a new version of it. So if, for example, you move your city 10 times in a year, or maybe in month, The data warehouse will have 10 record of yourself, and the latest record will be the most active, but there will be 9 record. But in transaction system, there will be only one record with your current residence area. The second reason of non-volatile is that you don't have to delete any record from your system. You just keep on adding more and more record and keep on accessing the data. Just imagine you have 3 years of data with you of food delivery app. You know this particular location in Delhi is somewhere this particular product is being sold a lot of time. Then you create a new pattern over it. Okay, if we introduce more restaurant or more cashback or payback time over there, then the customer order will definitely increase. That's why we need more data for analysis, for pattern matching, for doing some data science project analytics over it. Now the question arises, why does we need a data warehouse? Every organization has database in place for transaction system for recording transaction done on by customer. So why to introduce so much of money in creating a new department, a new team that would handle data warehouse? The first and foremost that you cannot run your analytics query on the production system. Just imagine you have a production system in place where 10,000 people are doing concurrent orders like food delivery app or e-commerce app. And on the same system, you are running your query that takes data for 3 to 5 years and you start doing analytics on that. Your customers, your end user will be highly affected because of your queries, because of your running your analytics query over there. So that's why we need a separate system. On that, we can run analytics query, data science project, and we don't want to stress our production system. Second is that we want a system that is optimized for read access. We don't want we will never update or record in data warehouse. We only keep on reading it. That's why we always want a system that is optimized for read access. The third, as mentioned before, integrated. In production, we have multiple systems. HR follows their own system. Sales team, they have their CRM. ERP has another team. Similarly, finance have their database. But we want to accumulate all the data from all the systems. That's why we need a separate data warehouse so that we can have all the data from there. Again, historical record in transaction system. What we do is that if somehow we want to keep a historical record, so we take a hard copy of it and keep it in a server or keep it in a safe or something where. But in data warehouse, there's a historical record available. You don't have to do any hard copy or something like that. You can go anytime, do the select star from your table and get the data from it there. Similarly, as I mentioned in the integrated one, you have to make a consistent copy of all the record. For example, in US dollars, their currency, in US, in Europe, it's Euro, in India, it's INR. So you cannot do comparison directly between US dollar revenue versus INR revenue. Instead, what you can do, you can create a data warehouse, have all the field there, have a consistent naming there, have a consistent currency over there, and do your analytics performs there. Another very important is that one version of truth is available in data warehouse. So that makes the very story very simpler for any leader across the department. It's not like that a leadership manager in finance is saying something and the leadership manager in HR is given different version. Because of data warehouse, we will have one version of truth available to us. Now, this is what we show. If we have a legacy application with us, with their own database, and we try to do reporting or analytics or save time building reports, it's a chaos. You have to consult with finance database also. You have to consult with marketing database also to get revenue. You have to consult with accounting team also. You have to consult with engineering team also what product you are building. On the other hand, if you have an enterprise data warehouse where all these systems are putting their data and you are creating a single version of truth, it would be very easy for me as a leader or as a manager that, okay, I need to know which of my product is doing a great business in this particular season of the year. So I can directly jump onto the enterprise data warehouse, put my question and get the answer. That's why enterprise data warehouse is equal to order, whereas legacy application but database equal to chaos. Nobody will get the correct answer. There will be chaos over there. But in EW, there will be pure order of the questions. You can ask any question you have. You will get the correct answer. That's why enterprise data warehouse means order. It means continuity, consolidation, control, compliance, and collaboration. As a leader, my focus is to get the right side of data. If I'm not able to get the right side of data, I will never get an answer to it. And if I don't have an answer, I will never make a decision over it. That's why the two purposes of data warehouse is one, save time in building reports, and number two, slice and dice. For example, I have the data with me from data warehouse. I can slice and dice into way. Okay, let's see what's the revenue was there last year. What's the revenue was there quarter on quarter, month on month. Let's see location wise. In North India, what's the sale? In South, what's the sale? Or okay, in geography, APAC is performing better than Africa or EMEA or US or Latin America. So all these questions you can easily answer by using enterprise data warehouse. Now comes that how is the data requirement of an enterprise mature with us time? Just imagine you have organization working there. The data is scattered locally. India team is using their own database and US team is using their own database. So any question arrives, what's the sale over there? So that's a reactive nature. You will start searching your data. Okay, 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 okay. In India, the sale is $50, but in the US, it's $80. So that is called stage one, reactive. The data is available but locally managed. So whatever happened, you react over it. Instead of taking preemptive action, you react to the scenario. The second stage is informatic, where data is managed and analyzed globally and centrally. It's not like it's locally, but centrally is there. And through data, you are able to create reports. You're able to create some business decision making process. But still, it's informative because you have just got the data, and data is not giving you output. You are going to data and getting the output. So it's a rear view mirror. The stage three is where every organization should target for enterprise data warehouse. That is predictive in nature. Data is captured comprehensively, it's scalable, and data is giving you prediction. Okay, if you follow this particular scenario, if you follow particular this policy, your revenue will increase, your growth will increase. So that is based on advanced analytics, and that is where most of the organization should focus on predictive. And the stage four is transformative. That is completely data driven business. Now business is driven through data. Data has transformed every decision of business. Any problem, any solution, any policy, data will give you the result. Okay, data will say, I have this data with me, I have this scalability is there, so you should do this. So the output of the final frontier for every organization should be transformative, where they are totally driven by data. And if you are driven by data, that's called real-time intelligence. So stage one and stage two is rear view, when you are looking at the back and then taking decision. Whereas stage three and stage four are like real-time intelligence. Beforehand, you know what you have to do because data is providing you that insight, that capability to take decision, and data is transforming your business. So this is something where data warehouse will definitely help organization reaching in their data maturity stages. Organization should not sit back and things to happen. No, they should take decision beforehand, and that could only happen if they have good amount of data, good quality of data in their place, so that they can give the answer to them instead of they going to the data and asking question. So just to summarize about data warehouse, like OLTP system, the transaction system I used to run the business, whereas data warehouses helps to optimize the business. If you know, in this current world, data is information. It's a very great asset to everyone. Reason being, data can give you those insights which even you can't ever imagine of. Like for example, Netflix recommendation engine is the best in the world. Reason being, they were able to optimize the data of customer pattern, how customer looks for a new movie, new show. So they will always, their recommendation engine will always provide good recommendation to the customer. And if that is happening very efficiently, then customer will spend more time on their platform instead of going to other OTT platform. Hence, it is very important to have a right data warehouse in place that will optimize their business. How can a leader use a data warehouse? That's a very important question because only on that basis he can create policy for his business. Like for example, I am a leader in my organization. I want to know which is the most distributed channel in the organization. For example, it's if my product is selling online or through channels, through stores. So if online sales is greater than the offline stores, then what's are the most effective way to increase the online sales? Should we improve the marketing over there? Should we improve the advertisement over there? Or should we keep on giving more offers to the customer so that they can bring in more revenue to the company? So these are the questions which data warehouse can answer for a leader. Like what product promotion have the biggest impact on revenue? What impact new product or service have on revenue and margin? Which customer are most likely to go to competition? I believe you all are using e-commerce application, food delivery app, ride hailing app. So they keep on giving you new promotion. And how are they able to identify? Because they know that this person is using this particular position A to B every day. So let's give him some new offer so that he become a more regular customer. And that could only be done because you have data in place with you. If my data says that person A travels from position A to B every day, So let's make that particular person a habitual of our application instead of doing someday. Let's give him an offer so that the person uses our product every day. And that's the way how you can increase your revenue, how can you increase your margin. And for that, data is very important, but the quality of data and how it is stored and how it is managed is equally important. And that's why data warehouse is very important in a current world. Now, there's a very common question among everyone who is learning data warehousing or who is starting their career. Like, what's the difference between data warehouse and data mart? Because these two words are used interchangeably very oftenly. Even organization does not know that when to go for which product, data warehouse or data mart. So, like data warehouse is a single organization repository which has data for across all or many subject area. Like it will have finance data, it will have HR data, sales data, customers data, revenue data, product data. So it will have all the data. Whereas data mart is a subset of data warehouse that is usually oriented to specific subject. So for example, we have very big data warehouse. We can create small data mart, like we can have one data mart specific to HR so that HR people only use that data. Although it will have data for all the units, but only HR people will use that data so that they know which data we have to use. Because HR data, the HR people does not care about what sales are going on, because they have to focus more on employees data, so they can have their own data. Similarly, sales team can have their own data mart. They can focus on hitting that data mart so that they can get data from sales, which sales product is going high, where the revenue are decreasing. So in totality, data warehouse is a very big unit which contains all the subject areas, and data mart is just one of those subject area. Now this is very interesting topic which is going on from years. In 1950s and 60s, Ralph Kimball and Bill Inman, the two founding father of data warehouse, they gave two theories, two philosophy, and everyone till now are still fighting which is best or which is better than the other one. Both of theories are good at their point. Both the theories have some pros and cons. It's up to the organization to adapt which philosophy is good for them. It's like that neither Kimball theory is bad or Inman theory is bad. It's just that how you try to interpret their philosophy and how your product looks like. But this controversial fight is always there since ages, and it will continue because both have given such a good philosophical around data warehouse that people are still using it. And some are using a mix of both, some are using individual, but both are correct on their space. So we will discuss about what is Kimball approach and what is Inman approach for creating a data warehouse. So the very basic difference between two is that Inman uses relational modeling, whereas Kimball uses dimensional modeling. Before going to theory, let's show us the example of that. In relational model, we have small table for each particular category. Like we have category table, brand table, product table on the left side, employee table, package table, product table. On the right side, we have dimensional model, which says that let's have less amount of table. We can have redundant data, but the amount of table will be less. So let's have one product table. It will have all the thing: product, category, brand, product color, weight, size, and we will have sales table. On the left side, if you see, there are different table for product, brand, category, package, product color, weight unit of measure, product size. But on the right side, all these tables are made into one table, that is product table. So the difference between relational model is that since there are multiple tables, the number of joins will increase. In dimensional model, there's only one table, product table, so number of joins will be reduced. The second difference is that since on the right side there's only one table, so it will have duplicacy of data. Like for example, product ID, product name is same for all, for product name like mobile category. The brand name will remain same. It will have Vivo 140, Vivo 142, Vivo 136. So brand name will remain same. Brand manager will remain same. Category name will always be same, mobile. So in that case, in product table, we have redundant data a lot, but in relational model, we don't have redundant data. So that's what this slide meant for. This in relational model, we have entity relationship model, many tables using join, whereas in dimension modeling, they are less table, but number of joins are less, but they have denormalized data. So the data duplicacy will be more in there. The dimensional modeling is good for people who want to use direct access of data, like non-IT users, like self-serve user, analyst, or people from sales and finance. They don't know how to use SQL or lot, so they can directly jump onto dimensional modeling and start getting data. Whereas relational modeling is of people who have more from an IT background. They know how to present data, how to accumulate all these data, how to create more table joins. So that's the big difference between Kimball and Inman. And the second difference is that the Kimball model says that let's create data mart which will accumulate to a data warehouse. So it's like bottom up approach. You start creating small data mart and logically it will be called a data warehouse. Whereas Inman says that let's create one big gigantic data warehouse. It will have all the data, and if you require you can create small data mart from that big gigantic data warehouse. The difference is like very simple. Kimball says that bottom up approach and Inman says top down approach. So Kimball says that logical data warehouse will be made up of subject area, that is data mart. It has only two layers, one for data mart, another for reporting. Whereas Inman says that let's create one big gigantic data warehouse. It will have all the data, and if required, then you can create data mart from the data warehouse. So it will have three layer: data warehouse, data mart, and then the cubics, then cubes or reporting layer. So this is what the example of Kimball model is like. On the left side, you have OLTP data sources, that is the source area, source tables, flat files, REST APIs, streaming data, Twitter, Facebook data, anything would be. The second layer is staging layer, where you just get all the data before cleansing. After cleansing, you store data into a data mart. And data mart in totality will be called a data warehouse. So it's a logical data warehouse, not a physical data warehouse. It will have data mart 1, 2, 3, and then you can use for reporting layer. So this is also a good approach. Reason being, for example, you have a small organization, you don't have budget to create a big data warehouse at first. So you can start with creating small data mart, and then you can start accumulating them to create a big data warehouse. The Inman model says that get the data and create one centralized data warehouse. This is very little bit tricky for organizations which are small in nature because they don't have so much of budget to invest in creating this data warehouse. But if you have the budget, if you have the visualization, so let's create one big data warehouse, get all the data from sources, put in a staging layer and do cleansing transformation, create a data warehouse, and if then require, create data mart as per the subject area you want. So HR can have different, finance can have different, sales can have different, and then the final is the reporting layer. So both the approaches have their pros and cons. It's just as the organization we have to decide which model we should choose, or we can club both the models also, like Inman and Kimball. We can start with bottoms up also and top down also. Let's create a big data warehouse, but take a very small piece of data mart from it and just build on over it. So it depends about the organization how they want to go into creating data warehouse, but both the approach are correct. They don't have any issues. It's just that how people look at it. So now we studied the two different approaches of data warehousing. One is Bill Inman and second is Ralph Kimball. Both are correct on their different aspect. So this is what data warehouse architecture look like. Little tweaks over and there is allowed, but it is what something looks like. On the left side, you have data sources. We have RDBM system, flat files. Then you have staging area. We get all the data from there. And in the warehouse, you store those data, metadata, summary data, raw data. You create data mart for it. For example, purchasing a different system, sales different, inventory different. And then finally, users could be for analytics purpose, for reporting, for data mining, anything. So this is what a typical data warehouse looks like. Small tweaks over and there is allowed. Ideally, it's like data source on one side, then you have warehouse in the center, and the end user using Power BI, Tableau, or whatever reporting tool they have for analytics purpose or for data mining. So two major concepts in data warehouses: fact and dimension. So fact is nothing but the measurable event to a functional area. Like for example, I say a growth of a company is $100. So $100 is a fact. Similarly, if in today's webinar, 40 people are attending, so 40 is the fact. So that's a measurable number. That's a number we have. But when I say $100, does it make any sense? It not. But when I say sales of product A at location B for calendar month October is $100, then it makes sense. So all these three terms, product, calendar month, and location, is a dimension. So dimensions are those attributes on which a fact is defined. So when I say 40 people attended the webinar, it does not make a sense. But when I say 40 people attended the webinar hosted by Analytics Vidya, given by Akash on the topic data warehouse is 40, then that makes sense. That gives some information to the leader. Similarly, So dimensions are the attribute on which information on which fact are defined, and fact are the measurable event. So like in this particular example, we have a sales fact in the middle and surrounded by product dimension, calendar dimension, customer dimension, and sales dimension. In the sales table, we have linkage to all the four tables. Like it will have link to product dimension, it will have link to calendar dimension, it will have link to person dimension, customer, and also the sales dimension. So at any point of time, I can run this sales fact query on this particular table and see how many product was sold on that particular day by particular salesperson or purchased by particular customer dimension customer. This sales fact holds all the information, and the dimensions are those that define that particular fact. So as an end user, as a leader, I need to know, okay, give me a sales of this product A for the month of October. So I could just query the sales fact table and get group by on product dimension and calendar dimension, and I will get all the records of there. Similarly, I want to know that if particular customer is an active customer, that means that this person is buying a lot. So give me a list of active customers who are ordering more than once in a week. So through sales fact table, I can get the information and I can give more offers to that particular customer so that that customer become more habitual to our website, to our application, and keeps on bringing business to us. So this is a very small example of what data warehouse looks like. Similarly, for others subject area, we will have similar data warehouse example. We will have a centralized fact table surrounded by dimension table. These dimension table will gives the attribute, and the fact table will gives the measurable amount. Now, if we talk about the data production timeline, like we initially did not have anything which can produce data or as a mode of communication. In 1500, it was a printing press. Then 1840s come the post, then telegraph, telephone, radio, TV, and now we have PCs, internet, and web. But if we talk about nowadays, every 60 seconds we are have at least 360,000 tweets every 60 seconds, and that this information is also some time back. So maybe now it has crossed 500,000 also. 3 TB new data every minute Facebook is getting processed. 41 million instant messages, 3.7 million Google search every 60 seconds. So just imagine the amount of data we are producing. And if we are not able to capture this data in our system, and we are not able to derive some information, some trend, some pattern, then this is of no use. And companies, organization which are able to capture this will be a leaders in future. That's why it's very important in current scenario to know the importance of data and the data warehousing. You store data, you get all the data, but if you're not able to use that data, then it's a junk for you. So it's like a dumping ground for you. You have just created dumping ground that is giving no information. So it's better to get the data, store the data, and utilize the data. If you're not able to utilize the data, then it's of no use. Now, if we talk about the history of data warehousing, how data warehousing in terms of technology got implemented. Initially in 90s or early 2000, people used to just follow the RDBMS mode where they have used to have single database. Everything was there on there in the on premises. So the processing speed was also slow and the storage was also very less. Then they moved to MPP, massively parallel processing system, where still the system was on premises, but the platform was efficient enough to generate the query and result very fast. The storage also increases, but the performance of the query is something that makes it more even efficient. Then by 2005 or 2005, 2010, we have big data where everyone has started using Hadoop, MapReduce, Spark, and that brings the whole change to the system. The amount of processing we are doing nowadays is immensely high. Similarly, the query performance also improves a lot. And if we talk about 2020, everyone is moving to cloud. Reason being, the flexibility cloud gives, you don't have to manage the on-premises technology, hardware, servers. So cloud is the future. And now cloud, we have Hadoop, MR, MapReduce, Hive, Spark again. So just imagine from one RDBMS to we are moved to cloud where we are getting so much of processing power, so much of storage, so that the data volume which is producing nowadays can be utilized. Now comes the question that everyone know that data is important. Everyone know how to create data warehouse. But why it is that people are not able to create a good data warehouse and get insight from it? I was in Gartner some time back. So there, I was working as a lead analytics engineer, and we have a team which used to do study for research on this particular topic. Why corporate data warehouse project fails? 70 to 80% corporate BI projects fail. So this is a very big number, and that's the reason why it's even more important to understand why what is data warehouse and how to implement it efficiently. 70 to 80% project failing means a lot of investment has gone there, but still is getting failed, and organization is not able to get insight from the project. And what's the reason behind the failing? The one is that we think that data warehousing is very easy. We always focus on transaction system. Let's create a great transaction system. The end user should have concurrent access. Let's have 20,000 concurrent access, even our system server won't get down. But they forget that data warehousing also requires same capacity, same investment, same technology mindset and people. So they think that data warehousing is very easy. Let's take it as a side project, assign 3 to 4 people over there and create whatever it's there. That's the biggest mistake they do. The second mistake they do is that they give a timeline. Okay, December 20 is then we have to launch the data warehouse, and then they start working backward. Data warehouse is never worked backward. It's always looking forward. You start a project, look forward, what we are trying to do, what question we have to answer it from data warehouse. So work in that particular scenario, looking forward rather than working backward. Another reason is that lack of user involvement. Data warehouse is not for the customer. It is for the leadership. It is for the management. So they should get involved in the creation of data warehouse. They should tell what types of question you are expecting this system to answer. Transaction system are for end users. End user should get a very good experience, UI experience, UX experience. Customer should not go into multiple window. In same window, they are ordering should be done, payment should be done, delivery should be done. But data warehouse is for leadership and the internal management. So they should get involved in creation of that. How, what level of question they are expecting the system should answer them. If you are just creating a system because sales supply chain company is looking for different questions, e-commerce company is looking for different question, similarly banking companies are looking for different question. That's why the people who will use this system should get involved by creating data warehouse. Another reason is that the people who are creating it and people who will be using it don't have much sync within them. People who are creating it does not have business requirement. So that's the reason they are creating as their own expectation, their own portfolio, their own views. They never know what business is looking for. Hence, it is important that business people and IT people both sit together and then create data warehouse. If I create a data warehouse that is suitable for banking, but maybe that is not suitable for supply chain companies because they are looking for different question, different answer, different pattern. Similarly, in insufficient architect design, data warehousing is not an easy project. Reason being, there are hardly few companies that are able to extract good amount of insight from warehouse. Hence, it's become very difficult to understand how to architect, how to design a data warehouse. The another reason is like choosing the wrong technology. In today's world, we have a long number of technologies available to implement data warehousing. It's not like that we just pick any database and name it a data warehousing. Just imagine RDBMS system using company using RDBMS as a data warehousing. It's a single node system. How it can perform to the data warehousing queries where you are analyzing at least 10 GB of data daily in every query. Will that single node technology work? No. So you have to always look out the query that can support mass storage and efficient query performance. Then only your data warehouse project will succeed. Now moving on to how we can make a project succeed. The last point in failure was choosing wrong technology, and the first point over here is choosing right technology. If we are able to use right technology, definitely our warehouse project will succeed. As I mentioned before, single node RDBMS database will never be an efficient data warehouse. So we have to look for a solution like Azure Data Synapse Analytics, or maybe in Google Cloud, or maybe in AWS Redshift, which can expand horizontally and vertically both. So that, for example, if we have to increase the storage, we can get it on the quick. Similarly, if we have to increase the performance, we can get on the rise. Similarly, choosing the right technology is very important for any project to succeed. The second is we have to understand all aspects of database architecture. If one company has implemented data warehouse using Kimball architecture, it doesn't mean that you have to do the same. You have to understand your use case, which Kimball approach is good for you in one. If your company is small in size, you don't have much sponsorship, much investment, so you can start creating small data mart and then bring in the complete picture at the end. Whereas Inman says that start the big enterprise at once and then create a data mart. So you have to see which is good for you. Similarly, relational modeling is good for you or dimensional modeling. So you have to understand from it. Find a project champion sponsor. This is very important. Data warehouse is not a easy project. Number one. Number two, it won't give you returns directly. Like transaction system project gives you return in as soon as it is launched. For example, you launch a new product in the market and you start taking ordering from your application. So it will keep you return directly from day one. But data warehouse project will give return after a lot of time because it will take a lot of time in building the project. Then leaders will start using it. Then they will start making more decision, started creating new policies. So it takes a lot of time. Hence, you require a project champion in terms of IT also and in terms of leadership managerial also because you want someone to invest your project. Another point is that agile approach to delivery with frequent releases. Instead of going for one big bang project, start with a very small project, very small subject area, which is small and easy. It could be high priority, but small and easy. Create it, implement it, launch it. Start doing some policy making from that particular database, particular data warehouse, and show that this have benefit and market it. You have to show the result also. Okay, if I have created a data warehouse for HR team, then my attrition rate is reducing by because I have started following this particular scenario, and now my attrition reduced from 16 to 12% in last 6 months. So you have to get the benefit also. And last and most importantly, get people trained about data warehouse. What is data warehouse? How it could help you? Not only for particular department. It's for whole company. Every organization, every team in the company should be data driven. It's not like the only sales team should be data driven. Everything in the company, everything in the organization should be data driven. Every action, every decision making should be based on data. Like data warehouse is saying that this is the right thing, that you should do this. If data is showing that this particular location is not performing well, so you should change your policy over there. Hence, everyone should get excited about data warehouse, data warehouse project, implementation, how to use it, and train them accordingly. This is what data warehouse is all about. We have studied what is data warehouse, what is not, architecture, Kimball, RAF, data mart, everything. Now, as we go into 2022 and the new technology or new philosophical study has been come, that is modern data warehouse. In modern data warehouse, what we are doing is that in the data warehouse, we are keeping raw data also and the transform data also. Since the storage has been reduced so immensely that in nowadays storage is not a cost factor. Nobody is focused upon storage. You can get 100 GB of storage in no value of today. Hence, the people have started using data warehouse as a data lake. You have a modern data warehouse, which means warehouse plus data lake. So data lake is nothing but, and if you see the ingest lake. So this is what you have all the raw data in the raw format. You have just clean it, but have it in a raw format that can be used by data science people for analytics, for pattern matching, for machine learning algorithm, for AI algorithm, all those for data modeling, for creating new models for pattern recovery or anything, whatever they want. So have the raw data in place over there and transform only the required data. Don't transform all the data. Only transform the required data that will be used by BI analysts for their day-to-day work, for getting data like who are my active customer, all those stuff. So this is what new modern data warehouse look like. You have a data lake plus data warehouse in picture. You will have raw data, which will be used by data science people using Spark, Hadoop, Scala, Python, any language. They can use it and they can generate models over it, and that can be used for predictive analysis, augmenting analytics, and all those stuff. And the transform data will be used through SQL by the BI analyst for the current and historical trend. So this is something which is very efficient in today's world because the storage is very cheap. We are not focused upon the cost of storage, but we are focused upon the result set. So if we can have something like this is known as data lake warehouse or modern data warehouse, where data lake is nothing but the collection of all the raw data, and in warehouse we will keep transform data which can be used through SQL, and as a complete, it could be used by any set of people. It's not like that only leaders will use this data. Anyone can use it who can bring out the new technology or new insights or new pattern matching. So in future, about of data warehouses, this only data lake. In nowadays, if for example you talk about companies, most of the companies are going to this direction. Let's have data lake with us. Let's ingest all the data, and whatever data is used by or is required, we will transform it, but we will keep it as a raw, because we don't want to invest our time in storing, in processing the transform data, because processing is something that is very cost effective. So we will only process and transform those transaction or those record or those data that is required by someone. Otherwise, we will keep it in a raw format. And if someone wants to use in a raw format, that's the best way to use it. Don't transform it. Earlier, we used to transform all the data as per our requirement of the leadership. But now we are keeping raw data, because raw data is something where Hadoop and Spark come into play, and they can transform in a very efficient way. You don't have to require warehouse to save the transform data, and that performance is improved a lot. Now you don't have to invest your resources in transformation, because storage is very cheap. That is fine, but the transformation engine is where most of the cost goes there. So you have minimized the cost by not transforming everything, but you are using open source technology so that you can do processing, you can do analysis, you can create models, you can do anything, but to get insights instead of transforming the data. So this is a very good study done by one of the research company, where they show why data is your differentiator. 63% of organizations realize a positive return on analytics investment within a year. 63% is a very big number. 69% of speed-driven analytics organizations created a positive impact on business outcome. Speed-driven analytics organization. So the important term is speed-driven. They are not waiting for things to happen. They are taking action beforehand. It's like predictive analytics. They are doing it. They know what will happen next, so they are already prepared for it. Instead of organization who are waiting for things to happen and that take action. 74% of respondents anticipate a speed at which executives expect new data-driven insight will continue to accelerate. It means that it's just the beginning. Data warehouse, modern data warehouse, data lake, it's just the beginning. Over the years, next 10 years, it will take everything on its own. Policy will be made as per the data, not by the people maker. Data will say do this, and company will definitely do this. Reason being, data is backed by 5 years, 10 years, maybe 15 years. So they have that insight with them. Hence, data is your differentiator as for now. Now we talk about database technology available in the cloud. So we have three big players in the cloud: AWS, Google, and Microsoft. All three offers all the required technology, compute service for the data warehouse. Like in AWS, we have S3, massive storage of there. Similarly, Google Cloud Storage, Azure Storage. So storage is of literally no cost as of today. For processing, you have compute, you have EC2 in AWS, we have virtual machines in Microsoft. In Google, you have Google Compute Engine. Similarly, Spark is available across all the three cloud. You can easily use it. MPP data warehouse in AWS is Redshift. Snowflake is third-party tool, but it's compatible with AWS. In Google, you have BigQuery. In Microsoft, you have Azure SQL data warehouse or Azure Synapse Analytics, which you can easily to get store data into a MPP data warehouse. Again, for data streaming, as I mentioned before, that data streaming is also one of the source in current scenario, because data is producing at a very rapid way, like three V's: velocity, volume, variety. So in AWS, you have Kinesis technology through which you can capture the data streaming. In Microsoft, you have Azure Stream. Again, for machine learning, cloud itself are giving their tool technology. You don't have to set up anything. You can just put your data, start working on it. SageMaker is there in AWS, TensorFlow in Google, ML Studio in Microsoft. So all these big players, AWS, Google, Microsoft, have given you a right platform for any organization to implement data warehouse. It's just the problem is that we think the data warehouse is very easy and we should just get the data and name it data warehouse. It's not like that. We have to do a complete modeling of data warehouse, and if given correctly and done implemented efficiently, it will definitely solve the many of the business problem, as and we show before also 63% positive impact within 1 year. That's a huge number. Similarly, 69% positive impact on business outcome. It's a huge number. But it also shows that 70 to 80% corporate BI project fails. And reason is simple, that data warehouse is a trendy term, so we should just create it. No, we should always think about, take a back step and think about it how we should create it. We should have IT champion over there, finance sponsorship should be there, user, the IT people and the business should interact with a lot, so that whatever it is building, it should be able to answer the question of the leaders or the management of the business. If system is not able to answer the question or the decision or the policy, then the system is nothing but a junk. So if you talk about the two people which are most important data warehouse, was Ralph Kimball. So there's a book written by him, the Data Warehouse Toolkit, exceptionally good book to all the required knowledge about data warehouse. Similarly, Billion Inman has written this book, Building the Data Warehouse, among the finest book of the data warehouse you will find over there. And the third person which I always refer to for data warehouse is James Serra. He has 35 years of experience in Microsoft, building data warehouse, data modeling, data management, data governance. So this guy is also one of the finest person in current scenario of data warehouse. So I always look up to him, understand what he's sharing. I also learn about him a lot from LinkedIn or from webinar he conducts. So you guys can also, if you're interested in data warehouse, read the book. Online is available. Also follow this person on LinkedIn. So he keeps on putting up good questions, good scenario. How should companies go for data warehouse? Think any questions anyone has, I'm open to it. Okay, so the first question is, let me go one by one. How it is different from data lake? Yeah. So as I mentioned before, data warehouse is like we are keeping the transformed data in place. But in data lake, we keep the raw data as well as the transformed data. By keeping the raw data in a data lake, we are giving a lot of opportunity for data science people to start using their models, their algorithm, so that it will give more result. Number one. And number two, we are not wasting our resources in performing transformation. Only the required performing is done, but we don't perform all the transformation or all the data. So this one question from Om Prakash is like, could you please explain why we have both database and data warehouse? Yeah. So databases keep for transaction processing. For example, you order a food from Swiggy, Zomato. So the information is saved somewhere. So that is database. That's a transaction system. Similarly, you order from Amazon, Flipkart. So all those information are saved in database. So that is a transactional database. So data warehouse is at the back end where the transaction system keep on pushing data to data warehouse, and that is used for historical analysis. Historical analysis is never done on the transactional database. One more question is like, what kind of cloud knowledge? It's it's not like that you have to be an expertise in cloud knowledge or you have to do all the three cloud. You can pick any of the cloud you like, because all the services are same. It's just that the vendors are different. So you can pick any of the cloud, any knowledge, has the basic knowledge, like S3 in AWS is for file storage. So how does it store the file? EC2 is for compute. How does EC2 works? EMR map reduce. How does it work? So understanding how it works is more important rather than knowing which cloud you know. How do we handle big data that cannot fit into our laptop? Oh, so it's like you can start with the free account from all the three cloud server. Like AWS also offer free student account. Similarly, Google also offer, Microsoft also offer. So you can start using their account, use their S3, fit on your data there, use their EC2. You can easily run your queries over there. It's not like you have to create a server in your own laptop. You can use free 1 month trial basis for any of the cloud provider. That's the best way to use it. Initially, I also used to use free student server also for all these three cloud. uh, how to speed up processing big data? See, it's like depend upon the volume of data you are processing. Whatever I have seen is that 50 to 60% project are something where the data volume does not increase more than 100 GB. And 100 GB is very small number for Hadoop processing. So if you have project with you which exceed 100 GB count of data, then you think about how can I handle it. But below 100 GB is very easily, even small database can handle it. So this has been answered, data warehouse and data lake. I have a question. 12 e-commerce website with the same DB structure. In my case, Slim Framework API in MySQL. How can I optimize my DB query and speed up using database? Like you have 12 e-commerce website and 12 DB structure. So instead of hitting those 12 e-commerce website and database, create one centralized data warehouse, get all the data on a batch processing. For example, you can have once a day processing. So at night 12 midnight, you can have all the data, incremental data from your e-commerce website database and push it into MySQL data warehouse, and then you can run your queries over there. In that way, it would be efficient instead of running your queries on individual database. From a practical standpoint, which data warehouse would you advise online? Can I get few tips to prepare a feasibility report? I didn't get this question. Can you rephrase it? What exactly are you trying to understand, Shiran? Or we can connect offline also. With the coming of automation, do you think there will be diminishing of it? No, no, no. However, automation comes, ADW will always be there. Automation is always on the processing side. It's not on the enterprise data warehouse. Enterprise data warehouse will be there. The tools and technology have been optimized. Like for example, nowadays you don't have to create your own node for Hadoop. EC2 is there. It will handle everything on your behalf. EMR is there. It will handle everything on your behalf. But the logic you have to write it, how you have to create your data warehouse, how you have to write your queries. That will always be there. Can I use MongoDB for data warehouse project? Definitely you can use. You can use any DB. It's not related that you have to use only Oracle or SQL Server. You can use any DB. How can I choose which database is good for data warehouse project? Yeah, the one thing you have to always uh, choose is that it should always provide flexibility for MPP database. Nowadays, all the database, Oracle, 12c, or maybe SQL Server, they are all are MPP database, so they will handle your data volume very easily. In previously, you don't used to have this MPP. We used to have single load database, which were not efficient. But when Teradata came in 2010, so it introduced the MPP structure, and nowadays all the database are MPP based. How data is being pushed from database to data warehouse continuously? Yeah, so for that we have to create a job. That could be, most of the jobs in data warehouse are batch processing. So like once a day or twice a day at 12 midnight, all the data from incremental data from database to data warehouse being pushed. Like just a small example, database table name is customer table. So we will create a job that will extract select star from customer table where change date is greater than today's date minus one. So it will extract all the previous data from database and push into data warehouse, and then we can process over there. Can data warehouse be hosted on cloud? Definitely, it could be. There is nothing as of now which cannot be hosted on cloud. Everything is there. What is the pathway to be expert in data problem solving? See, SQL is one thing, and second, any programming language. If you are good in SQL plus any programming language, it could be Scala, it could be Python, it could be R, it could be Java, any programming language for handling huge amount of data, and SQL for database related project. That's two is enough to be good or expert in whatever sense for data problem solving. Data scientist versus data engineer for a fresher, which one would you suggest considering opportunities? Both are fine. Don't go for role name, data scientist or data engineer. Don't go for role, go for competency. If you know SQL, if you know programming language, you can go for any of the stream like data scientist, data engineer. Go for competency, learn SQL, get expertise in there, learn any programming language. It's not that you have to learn only Python. If you know Python and your company is doing Scala, you can directly jump onto Scala. There's nothing wrong. You can adapt to it. But if you don't know Python, if you don't know Scala, you don't know even Java, then it would be very difficult to jump on. But if you know any programming language, because Java, Scala, Python all follow same principle, OOPS principle. So if you know the logic of it, you know the base of it. It's just a syntax and semantics is something that you can learn over time. You can Google it. Even experienced people do. There's nothing harm in that. But the syntax and semantics can be easily learned. But the logic creation is something you should know. So the title does not matter whether it's data scientist or data engineer or big data engineer. All are same. you should always go and mastery the technology. And by technology, I don't mean the tools. Technology means Java, OOPS concept. OOPS concept remains same everywhere. Polymorphism remains everywhere. Encapsulation remains same everywhere. Similarly, in SQL, joins remains same. Whichever database you use, some small tweaks will be there, but the concept of joins remains same. Similarly, aggregation remains same. Group by remains same. Only the small syntax change will be there, but the logic creation will remain same. What are the use of how to transition to data warehouse if you're experienced person? See, understanding database is very important. What is database and how does database work? And then you can transition to the data warehouse if you have interest on data, because data is something which you should be habitual to it. The volume of data increases, then the query creation become even more important. You should know how to create good query. That query should give the performance. Like, just take a small example. Your table has 100 data. Whatever query you write, however bad it is, it will give result in 10 seconds. But just imagine the same table has 10 GB of data now. Will your query give the performance in 10 seconds? It will not. So always focus on writing the query that is scalable. Just imagine that uh, you are working for a company where you created a project or a product. It is working fine for 3 months, but after that the volume increase of data. And if does not work, then your product quality will be questioned. Reason being, after 2 years, 3 years, every product go into reinvention. That is fine. But if your product is not able to fulfill the solution for 3 months also, that means there's something wrong in your query. So always does not look for the data volume, look for how efficiently this query will work even after 3 months. Can we use Snowflake as a data warehouse? Definitely it will. Snowflake is meant for data warehouse only. What resources can you recommend for a self-learner? In today's world, YouTube is the biggest learner. You can go to YouTube and search for any topic. You will have hundred of topics. Pick any two session. You would definitely get information more than if you go through like 10 of thousands of courses. So it's better that you should think what you have to study. If you are interested in data, then only go for this particular course. If you are not interested for data, you are just doing because all other people are doing, then it will be very difficult for you to cope up because they have interest. And once you have interest in particular technology, particular tool, particular topic, you tend to give more. So first create your interest in data, then only you should try for these type of course. I think it's how data warehouse different from S3 and GCS. Okay, so S3 and Google Cloud Storage is just a storage. You put all the data over there, but can as a business leader or a business manager, I can get information from it? No, it's a plain data in S3 or GCS. It's plain data. But if I transform the data into something and then again store into S3, then data warehouse is called. It is different. As I mentioned in the previously in the first slide, that data warehouse is not a dumping ground. It's not like you just dump all the data in S3 and your data warehouse is prepared. One S3 file says that $100 is the amount of revenue. One S3 file says $10, and one S3 file says ₹5. So does 100 plus 10 plus 5 equal to 120? No, it won't, because 5 INR is different and $100 is different. So you have to make it consistent. And then if you save in S3, then that is data warehouse. There's nothing wrong in that, but you have to make it consistent, transform it into one unit, into one currency. Then you can call it data warehouse. But just dumping your data into S3 or Google Cloud Storage does not make it a data warehouse. I think most of the questions are answered. So if you have any question, no issues, even after also the session, you can come to my LinkedIn profile. We can connect over there. Discussion is very important. If you have any question about data warehouse, data engineering, email me or send a message on LinkedIn. I am happy to answer anytime. How data warehouse different from Apache? It's the same. See, Apache Lakehouse is like we have saved the raw data. Just imagine, can a business leader get something from Apache Lakehouse if it is not transformed, or if it is not in a suitable format which he can read? Apache Lakehouse has data in Parquet format. Can a person of non-IT background read it? No, he won't be able to read it. So have a Apache Lakehouse, build a model over it, and the output of the model should serve to the purpose of the business leader. So whatever you are preparing it and wherever you are preparing it, it should give output to someone who is from non-IT and is of some values. You can have Apache Lakehouse, it's fine. You can have data over there, but build a model over it, and those models should give answers to the business people so that they can create new policies for them, for the organization. If not, then I think we are good to close.
Okay, I think it's time now.